Hey guys, and welcome back on my YouTube video. Today's video, I'm going to be creating a pretty cool and advanced neural network in Python, and it can detect cancer cells. So it's going to be a cancer cell detector neural network. So it's going to be pretty good. I have not actually installed what do you say TensorFlow on my Sublime text file. But the reason why I'm using it is just because I really like the editor. So I will be compiling and executing the code in the Google Colab, but the code is going to be different. So let me just save it up. So setting the network. So I'm just going to go ahead and import TensorFlow as TS, and from the TensorFlow module we will import Keras. I'm going to import NumPy as NP, and from matplotlib I'm going to import pyplot as plt. So these are the imports, and I require one last module, the TensorFlow dataset. So import TensorFlow datasets as TFDS. So these are the modules we are going to be using. So the first step we need to do is load in uh, data. To do that, it's pretty simple. But before that, I think we need to do one last step. I'm just going to type out tfds dot disable underscore progress underscore bar. And now let me go ahead and load in the data. So I'm going to be working with the collectoral history neural network. I've already made this. So let me actually copy this, and actually let me show it over here. So you can see it classifies collect this type of cancer. So the class names for this are pretty complicated, like stroma, complex, lympho, debris, mucosa, adiposa. So I think I also need a new notebook. Let it load. Let me just save it as. So first let's just go ahead and load in our data. And I'm just going to type out tfds dot, actually you know what, we'll just type out builder is equals to tfds dot builder, and then we just put in the name of the dataset we want to work with. So colorectal histology, pretty complex name. So now what I will do is I will get some information on it. So get information in the dataset. To do that, we type out info is equal to builder.info, and now we need to put in the name we want to get info on. So colorectal histology, and I can just go info. Alright, I just remembered I not installed TensorFlow, so I'll need to copy this and paste. This white thing really hurts my eyes, so that's why I'm writing from here. Alright, so we'll get some info on this. Dataset info is valuable. Alright, oh, I just remember we don't need this. Alright, so you can see it tells name colorectal histology. So the description is what is given over here. So you can, without going on the TensorFlow website, you can just get yourself some info. So that's pretty good. So now that we have gotten some info on this, I'm actually gonna get rid of this code because we don't actually need it now. So now let's just split thing into three. So to do that, we just type out df_train is equals to dfds dot load, and inside we just type out again the name of the package. So call it activist.g. So paste it down here, and we just give it a split of train, and I just type out ds underscore test is equals to dfds dot load this package with this left. So now that we have done that, we can actually go ahead and convert all of these into a numpy format. To do that, I'll just type up train underscore images is equals to uh, np.array. So it's going to be an array. Inside, it's going to be containing an example of an image. Now what we also want to do is we want to convert it to a numpy format, and we also want to convert the image that we are using to a grayscale. So we just write this code and so just convert anything that we want into a grayscale. So that's how it works. So now we just make a simple for loop. So for example in ds train, and we just end it. So if you do not understand what I did over here, this is basically a list comprehension. It's a pretty cool thing that you can make the entire function or a for loop inside of a list. So now I will need to do this same thing for the train labels. So it's going to be pretty similar to what we did over here in the train images. So now I will again put in the example. And instead of having a look at the image, we will have a look at the label, convert it to a numpy format. But over here we don't need to convert any label into a grayscale, so we will just simply put in for example ds. So once we do that, what we can simply do is just copy these and paste it down here. And what we want to do is just convert it to test images and ds underscore test, and we also want to convert this guy to test labels, and this one also ds test. So once we do that, we should all of these images converted to NLP format. The reason why I'm not running the code right now is because we are not going to be getting any output from that. So let's now convert all of these to a float, so we can actually divide these by 255. So I'll just type out train underscore images is equals to train underscore images dot as type. I feel like it's a single s, and we want to go to as type of float 32 and test underscore images is equals to test underscore images dot as type as float 32. So now these are our floats. So if you will go ahead and print the type of them, they will be known as a float rather than these ints which they were previously. So now what I will do is just type out train underscore images is equals to train underscore images divided by 255.0, and test underscore images is equals to test underscore images divided by 255.0. So So if we do this, we convert like all of these to a value which is lesser than 255, because if you know an RGB value extends till 255. So now what I will do is I will go ahead and define the class name. So define the class names. So I'm simply going to copy paste the class names. Network. So you guys can just copy these in by yourselves. Alright, so these are of the class names which we just put. You guys can copy that in, or else I will also have the code on GitHub which you can have a look at. So now to create the model. So the model we are gonna be going with, at least me. I'm not going to go with the convolutionary approach because, as I told you, I have just made a video on convolutionary neural networks and I want you guys to implement it by yourselves. So I will go with the standard dense approach. Um, the network that I'm creating right now is not going to be the high accurate model, because as I told you, I'm not using any convolutions and I am keeping them as a challenge for you guys. To do that, I'm just going to define model is equals to keras dot sequential, and then we just put the round brackets and the square brackets, and we can now add the layers inside. I'm going to go ahead and add a dense layer to the model. The reason being, I'm sorry, first let me go ahead and add a flatten layer, just to push up our data. And now we are going to go ahead and add a lot of dense layers. So keras dot layers dot dense. Let's just go with some high neuron count, node count like 1900, and then activation of a rectified linear unit, or also known as ReLU. We will need to add another dense layer, so keras dot layers dot dense. And then the last to last video I also talked about how you need to place the nodes in your dense layer, so you guys can check that out if you are having trouble understanding why I'm putting the dense layer with these many nodes. The second one, I'm going to go 1600 and a activation of ReLU again. We are going to go with the ReLU activation for all of the dense layers and the softmax activation for the output layer. So keras dot layers dot dense. This time I'm going to go with 1200 nodes and again the same activation. And one, I think the second last dense layer. So keras dot layers dot dense. 950 activation of ReLU keras dot layers dot dense. 7 no 500 and the activation of ReLU, and I feel like I will need one more layer before the upload. So keras dot layers dot dense 250 and in activation of ReLU. Alright, so we are going to take good neural network. So if you guys are not that familiar with neural networks, you definitely are after creating such a big one. We are going to be needing the output layer now, so keras dot layers dot dense. And even in my previous video I mentioned that the output layer has the amount of nodes as the amount of class names, because these are the amount of predictions the model can make. So if you add any more or less nodes, it's just going to affect the accuracy of the ball. So 1, 2, 3, 4, 5, 6, 7, 8. So it will go with 8 and a activation of softmax. There we go. So we have successfully created the model. So now I'm just going to go model.compile to compile the model. So we are going to give it a optimizer of Adam. Now what I recommend you guys do is just search for optimizer examples and use some different optimizer. You can use something like RMS crop. You can use something like, there are a lot of optimizers out there for TensorFlow 2.0. So just go ahead and search for some good optimizers that work over here. The laws that we are going to be going with is going to be sparse categorical cross entropy. Binary cross entropy does not actually work in such type of an example. So sparse underscore categorical underscore cross entropy, and obviously the matrix is going to be as accuracy. So once we do that, we have compiled a model, but we yet need to fit it. So model dot fit, and we can just pass it the parameters of train images, comma, train labels, and epochs as 7 for now. The reason being the model is pretty large, so if we put something like 50 epochs, it's gonna take a lot of time, even if we are using a GPU. And a batch size of, say, 30. Now what we will do is make and display the predictions. So we will now make and display predictions. It's pretty simple. All we do is just type out predict is equals to model.predict the test images, and then what I want to do is display it using matplotlib. So for I in range, it's going to be, let's just go 15 for now. No, let's just go 5. Let's just go 5. Actually, you know what? 15 seems good. We just want to do plt dot grid as false. You want to do plt dot im show test underscore images at the ith index, and the cmap as plt.cm.binary, and we also want to do plt.xlabel as actual, and which will be equal to the class names test labels of the ith index, and also it will be plt.title the prediction that the computer makes, which will going to be the class names. We are going to be just doing an argmax, so np.argmax, so prediction of the ith index. So this is the entire neural network. It's a bit complicated, but really good, and it is pretty interesting. So let me copy it and paste it down here. So I quickly made it and time to write. So it'll take a second or two. It's a pretty, you can see the amount of layers are pretty. So it's taking a lot of time. Am I using a GPU or not? Alright, I'm using a GPU, but still it's taking a lot of time. Don't know why, but whatever. Why is it taking me so much of time? Like, I've already made this guy. Like, you can see it's making these predictions. So if I think this guy does not want to behave, I will just show you guys this. Why is it taking so much of time? Is it something wrong with my internet? Alright, it's downloaded. So now we should run through the box. But before that, we need to do this, and the class names, and we will use. This will take a lot of time because the box is 7, even though the batch size is 30 only, and the amount of nodes is pretty high, like it's about 4,000 something nodes. But still, you can see it's so fast because of the GPU. It's actually showing it. Alright, what happened? Prediction is not defined. Predict. Alright, alright. Predict. I need to change it to prediction. Now I now I will need to download all of this again. That's bad. I should have changed it into one of those cells. At least it would have executed the code quickly. But I'm pretty happy with the model that we have so far. It's it's a really good little model that we can bang out, and it's also very good. Alright, so advanced with the epoxy, you can see it's not the best accuracy right now. Why is it just showing one guy? It should show 15. Wait a second. I don't know. Let me have a look. Let me copy this and paste it down there. And also paste it in here. I feel like this should do the things. You guys can check what was wrong. Oh, it was just displaying all of the things that we are not appreciating. Yeah. Come on, why is it taking so much of time? But let me tell that time to show you quickly. So it's like if we stroma tumor, it's adipose tumor, tumor. So you can see how it's working. So there we go, we get the output that we needed. So stoma, tumor, lympho, empty, adipose. That's correct. Debris. So as I told you, I have not run through a lot of epochs, which you can increase obviously. You will need to give it something like 30 epochs. Otherwise, obviously, it's not going to give you the best accuracy with only 7 of them. Knowing that the data is something like a gigabyte. I don't know where to show you, but it's a gigabyte of information. So it's not the smallest data set you will find. It's actually pretty large. Alright, so it will run to debox and get yourself equal accuracy. Obviously, you will need to play around with the nodes and get this kind of a input shape, but I'm not going to do that because it will work fairly well now. You can see it reached to a 50%. Alright, so that's it for this video. If you did like this video, comment down below, subscribe to the channel, and until the next time we meet,